அனைவருக்கும் வணக்கம். வெல்கம் டு பிகே கெமிஸ்ட்ரி. இப்பகுதியில் நாம் கெமிக்கல் கைனடிக் ஷார்ட் நோட்ஸ் பார்க்க இருப்போம். வாங்க வீடியோக்குள்ளே போகலாம். ரேட் ஆஃப் ரியாக்ஷன் A gives B, therefore rate equal to minus dA by dt or plus dB by dt. செறிவுகளுடைய ரியாக்டண்டோட செறிவு குறைய ப்ராடக்டோட செறிவு அதிகரிக்கும். எம்பிரிக்கல் ரேட் லா ஈக்குவேஷன் is only experimental found method. A gives B, therefore rate directly proportional to the concentration or rate equal to K into concentration. K is a rate constant. Or third order type, AA plus BB plus CC gives B, therefore rate equal to K into AA, BB and CC. The rate law equation is directly proportional to the K into concentration. Therefore, K equal to rate divided by concentration. Third, unit of the rate. Generally, unit of the rate is assumed mole liter inverse time inverse or mole liter inverse second inverse. In gas-phase reaction, the unit of rate equal to atom second inverse. Fourth, order of the reaction. The order of the reaction is defined by the sum of the power to which the concentration or pressure terms arise in rate law equation in order of the reaction. செறிவுகளுடைய கூட்டுத்தொகையை நம்ம ரேட் லான்னு சொல்கிறோம். எக்ஸாம்பிள், MA plus NB gives products rate equal to K A power M B power N. Therefore, order of reaction equal to M plus N. 3 example பார்க்கலாம். First example, the nitrogen pentoxide decomposition reaction rate equal to K N2O5 power 1. Therefore, order equal to first order reaction. Example 2, hydrogen iodide formation R equal to K hydrogen 1 iodine 1. Therefore, order 1 plus 1 equal to 2. Therefore, is a second order reaction. Third example, nitrosyl chloride formation reaction. Therefore, order equal to 2 plus 1 equal to 3. Therefore, third order reaction. Fifth, the generally nth order of the reaction, the various rate constant, unit and T of is given by rate constant equal to Kn equal to 1 by n minus 1, 1 by a power n minus 1 minus 1 by a naught power n minus 1. The unit of the nth order reaction equal to mole power 1 by n decimeter cube or liter power n minus 1 second inverse or mole liter power n minus 1 second inverse. The half-life period of the nth order reaction T of equal to 2 power n minus 1 minus 1 divided by Kn n minus 1 a naught power n minus 1 or T of equal to 1 by a naught power n minus 1 or 1 by a naught power n minus 1. Capital A or small a எதாவது நம்ம பயன்படுத்திக்கலாம். Sixth, molecularity is defined by the total number of reactant molecules that are involved in the elementary step of the chemical reaction. ஒரு வேதிவினையின் ஒவ்வொரு படிநிலைகளுக்கும் ஈடுபடக்கூடிய ரியாக்டன்டோடைய எண்ணிக்கையை நம்ம மாலிகுலாரிட்டின்னு சொல்கிறோம். எக்ஸாம்பிள், nitrogen pentoxide decomposition is unimolecular reaction, hydrogen iodide formation bimolecular reaction, sulfur trioxide formation trimolecular reactions. Sixth, seventh, first order reaction. Example, the various example is available. Some important example is given by inversion of canned sugar. Generally, inversion of canned sugar also called pseudo first order reaction and first order reaction. Sucrose is hydrolysis to form of the glucose plus fructose. The decomposition of the hydrogen peroxide, dehydration of the oxalic acid, nitrogen pentoxide decomposition reaction, அனைத்து ரேடியோ ஆக்டிவிட்டி எலமெண்ட்ஸ் டிஸ்இன்கிரேட்டட் சிதைவு வினைகளும் முதல் வகை வினையே. எக்ஸாம்பிள், A gives B, என்ற வேதி வினையினுக்கான ரேட் கான்ஸ்டன்ட் K1 ஈக்குவல் டு 1/T ln A0/A அல்லது K1 ஈக்குவல் டு 2.303 டிவைடட் பை T log A0/A அல்லது K1 ஈக்குவல் டு 2.303 டிவைடட் பை T2 மைனஸ் T1 log A1/A2 அல்லது K1 ஈக்குவல் டு 2.303 பை T log A/A0. முதல் வகை வினைக்கான அலகு செகண்ட் இன்வர்ஸ். ஃபார் கேஸ் ஸ்பேஸ் ரியாக்ஷன் the rate first order rate constant equal to 2.303 by T log partial pressure of I divided by partial pressure of I minus partial pressure by X. For time dependent equation T equal to 2.303 divided by K log N into N by N minus 1. முதல் வகை வினைக்கான அரைவாயு காலம் T of equal to 0.6932 divided by K. The half-life period of the first order reaction is independent of the initial concentration of the reactant. முதல் வகை வினையின் அரைவாயு காலம் ரியாக்டனுடைய செறிவை பொறுத்து அமையாது. 6. The various graphical representation of the first order reaction concentration is time, ln concentration versus T, concentration versus time, rate versus C concentration, log C versus T, rate versus T. 7th type also possible, log A versus T. The various slope is available. 8. Second order reaction. The various example available. The saponification of ethyl acetate, ozone decomposition reaction, nitrogen oxide decomposition, hydrogen iodide decomposition. The second order reactions is from the two type of the reaction. The both reactant are same or both reactant are different. First A type, the both reactant are the same type. 2A gives P. The unit is mole inverse liter second inverse. Therefore, rate constant K2 equal to 1 by T 1 by A minus X minus 1 by A, or K2 equal to 1 by T X divided by A into A minus X, or K2 equal to 1 by T into 1 by A minus 1 A naught. When the reactant are different, the unit equal to mole minus 2 liter second inverse. A plus B gives product. Therefore, rate constant K2 equal to 1 by B minus A T ln A into B minus X divided by B divided by A minus X, or K2 equal to 2.303 T A minus B log B into A minus X A into B minus X. The half-life period of the second order reaction, the half-life, the inversely proportional to the concentration. Therefore, T of equal to 1 by K to A naught. The graphical representation of the two type of the reaction is available, and A type and B type. The A type, rate versus concentration. The B type, the total value of the concentration of the product versus time. From K equal to 1 by T equation, the graph is available 1 by A versus time. Ninth type, the pseudo first order reaction and the second order reaction. One reactant to excess or constant. These reactions called pseudo first order reaction. Example, hydrolysis of ethyl acetate and also inversion of the cane sugar. 10th, third order reaction. The third order reaction is classified into the three types. The both reactant are same. Second, two reactant are same, one are different. Third type, the three reactant are different. Type A, 3A gives P. Therefore, rate constant K3 equal to 1 by 2T into 1 by A minus X square minus 1 by A square, or K3 equal to 1 by T2 into X into 2a minus x divided by a square into a minus x square. The unit of the type A, mole minus 2 liter square second inverse. Second type, 2a plus b gives product, or a plus 2b gives p. The rate constant K3 equal to this type, 1 by t into 2b minus a square into 2x 2b minus a divided by a into a minus 2x plus ln b into a minus 2x divided by a into b minus x. The third type, a plus b plus c gives product. The rate constant this type equal to 1 by t b minus c ln a minus x by a plus c minus a ln b minus x by b plus a minus b ln c minus x by c divided by a minus b into b minus c into c minus a. இது பார்ப்பதற்கு பெரிதாக இருந்தாலும் ரொம்ப சுலபமானது. ஃபஸ்ட்டு பார்த்திங்கன்னா b மைனஸ் சி, therefore இதில் a இல்லை, therefore ln a மைனஸ் x by a plus c minus a, இதில் b இல்லை, therefore ln b minus x by a, the vice versa. The half-life period of the third order reaction T of equal to 3 divided by 2k3 into 1 by a square, or T of equal to k prime divided by a square. இந்த இடத்துல k prime ஆனது 3 by 2 into k3க்கு சமமாக இருக்கும். The example of the third order reaction is given by 11th. Zero order reaction, A gives P, rate equal to K, concentration A power 0. ரியாக்டண்டோட செறிவை பொறுத்து அமையாமல் நடக்கக்கூடிய வினைகள் பூஜ்ய வகை வினைகள் என்று அழைக்கப்படுகிறது. இதனுடைய ரேட் கான்ஸ்டன்ட் K நாட் ஈக்குவல் டு A நாட் மைனஸ் A divided by T, or K naught equal to x by t. The half-life period of the zero order reaction, half-life period directly proportional to the initial concentration of the reactor, or T of equal to A naught by 2k, or T of equal to k prime A naught. இதனுடைய அலகு mole liter inverse and second inverse. இதனுடைய graphical representation of the zero order reaction, rate versus T, concentration versus T. The example of the zero order reaction, all photochemical reaction, all metal surface reaction, photosynthesis biological reaction, iodination of the acetone in acid catalysis, and hydrogen iodide decomposition in the presence of gold. 12th, fractional order of reaction. The fractional order also is available. Example, hydrogen to react with deuterium to form of the hydrogen deuterium. Second time, astrolligate the decomposition of the methane with the carbonyl. The first is order equal to 1 plus 1 by 2, therefore equal to 3 by 2. The rate constant fractional equal to 2 by T of a power 1 by 2 minus a minus a by 2 whole power 1 by 2, or K fractional equal to 2 by T of a power 1 by 2 minus a by 2 whole power 1 by 2. The half-life period of the fractional equal to 2 by k fractional rate constant root a into 1 minus 0.5 whole power 0.5. Therefore T of equal to 0.586 into root a divided by k fractional. 13. Negative order of reaction is the example of the decomposition or formation of the ozone. The order is equal to -1. The relationship for the first order reaction for mathematical purpose, the time. Third type, T 1 by 4 divided by T of equal to 0.415 into T of. Fourth type, T 3 by 4 divided by T 1 by 2 equal to 2. 15. The Arrhenius equation is very important. The effect of temperature on reaction rate. Like 3 type பார்க்க போகிறோம். First Arrhenius equation. The Arrhenius equations d ln k divided by dt equal to EA by RT square. இதனுடைய logarithm form of K equal to A into e power minus A by RT. K rate constant, A frequency factor, E activation energy, R gas constant, T temperature. இந்த இடத்துல T 0 or infinity இருக்கும் பட்சத்தில் K always equal to the frequency factor A. The ln K2 by K1 equal to EA by R. Therefore T2 minus T1 divided by T1 T2, or log K1 by K2 equal to EA by 2.303 R into T2 minus T1 divided by T1 T2, or log K2 minus log K1 equal to EA divided by 2.303 R T2 minus T1 divided by T1 T2. T2 always is greater than. The graphical form of the Arrhenius equation is two types: log K versus 1 by T, K versus T. Therefore slope equal to minus EA by 2.303. The log K equal to log A minus EA by 2.303. The Arrhenius equation is derived from the want of equation. The want of equation is d ln K equilibrium divided by dt equal to del H divided by RT square. For mathematical purpose, we know e power 0 equal to 1, e power infinity equal to infinity, e power minus infinity equal to 0. B. The signification of the activation energy. The potential energy versus reaction coordinate. If reactant is greater than, the reaction is endothermic. The product is greater than, the reaction is exothermic. A equal to activation energy. Third, temperature coefficient of the reaction rate. The temperature coefficient equal to rate constant at temperature plus 10 Kelvin divided by rate constant at temperature. General formula 2 power n. ஒரு டிகிரி உயர்த்த ரேட் கான்ஸ்டன்ட் மதிப்பு 10 உயரம் வெப்பநிலை. Temperature increase by 10 degree, usually the rate will be the 2 times. வெப்பநிலையை 10 டிகிரி உயர்த்த ரேட் கான்ஸ்டன்ட் 2 மடங்கு உயரக்கூடிய வாய்ப்பு இருக்குது. Example, the temperature coefficient equal to Kelvin at 35 degrees Celsius divided by Kelvin into 25 degrees Celsius. Therefore, equal to 2. The taking activation energy equal to 85 kilojoule mole inverse. The temperature coefficient of the reaction is found between 300 and 310 Kelvin. 16. The theories of the reaction rate. The various theory is available. 3 important theory now we will discuss: collision theory, ACT, or TST, or ART. Activation complex theory, transition state theory. The Linnemann theory. First, collision theory. A plus B gives AB. இந்த இடத்துல நம்ம தேரியை டிஸ்கஷன் பண்ணாமல் முக்கியமான டேர்ம்ஸ் மட்டும் பார்க்கலாம். கொலிஷன் நம்பர் Z ஈக்குவல் டு ZAA ஈக்குவல் டு 1/2 √2 pi d ஸ்கொயர் மியூ பார் NA ஸ்கொயர். இதனுடைய யூனிட் மீட்டர் -3 செகண்ட் இன்வர்ஸ். மியூ பார் ஈக்குவல் டு √8 pi KT by m. Or ZAA equal to 2n square d square 8 pi KT divided by mu whole power 2 whole power 1/2. The ZAA equal to 2 d square NA square pi KT by m whole power 1/2. ZAB equal to NA NB d square 8 pi KT divided by mu 1/2. The rate constant K equal to 2 d square NA square 8 pi K 1/2 by m exponential power minus EA by RT, or NA NB DAV square 8 pi KT divided by mu whole power 1/2 exponential power minus EA by RT. The steric factor rho, R equal to rho into Z into exponential minus EA by RT. The steric factor is also available 1 to 10 power minus 9 unit. The theory only valid translation motion, not valid rotational and vibrational, and only applicable to the simple gaseous molecule, is not applicable to complicated gaseous molecule. Example, hydrogen iodide formation reaction rate at 556 Kelvin, 3.7 into 10 power minus 7 it has one inverse and the second inverse. The Z equal to plus 0.92 root of 3RT by M. 18. Transition state theory, A plus B, the activated complex form, decompose the product. Two types of graph is available, potential energy versus reaction coordinate. If product is high, the term is exothermic, the reactant is the term is endothermic. The transmission coefficient is always unity. The value equal to K equal to small k, KBD divided by H, Q activated divided by QA QB exponential power minus A by RT. The Eyring equation, very important equation for transition state theory, K equal to KP T divided by H exponential power del S naught divided by R activated exponential minus del H naught activated divided by RT. 19. The Linneman theory, A gives P. Therefore, rate constant K equal to K2 K1 A square divided by K2 plus K minus 1A. For higher pressure is first order, the lower pressure is the second order. The graph is available, rate versus A, 1 by K versus 1 by M. First slope is K2 by K1, second slope is 1 by K1. And last, enzyme kinetics mechanism, enzyme plus substrate. To form up the enzyme substrate complex, decompose a product plus enzyme. The very important equation is Michaelis-Menten equation, rate equal to K2 E naught S divided by Km plus S. When substrate is very low, the rate equal to first order. Therefore, rate equal to K2 E naught S divided by Km. If substrate is very high, rate equal to K2 into E naught. The reaction is zero order. When E naught equal to S equal, therefore rate equal to K2 E naught. This also is called Vmax. This number K2 is called turnover number, is a catalytic efficiency term. Therefore K2 equal to R max or Vmax divided by E naught. Therefore rate equal to R max plus into S divided by S plus Km, where Km equal to K minus 1 plus K2 divided by K1, and substrate equal to Km, the rate equal to Vmax divided by 2. The graph is rate versus substrate. Therefore, maximum rate is 0 order, the minimum rate is first order. The two type of the plot is now available of the enzyme kinetic mechanism. First one is Lane-Weber plot, is Y 1 by R rate equal to Km divided by R max into substrate plus 1 by R max. Therefore, graph is 1 by rate versus 1 by S. Therefore, intercept equal to 1 by R max, slope equal to Km by R max, or R max equal to Km by slope. The negative intercept also is valid, minus 1 by Km. Second plot is Addy-Opsty plot. This is rate divided by S equal to minus rate divided by M Km plus R max divided by Km. The two type of graph is available, rate versus rate by S, rate by S versus rate. Effect of change pH and temperature on enzyme kinetic reaction. The optimum pH range is 7 plus or minus 1. The optimum temperature 37 degrees Celsius. Therefore, இந்த வீடியோவில் நம்ம கெமிக்கல் கைனெட்டிக்ஸ் முக்கியமான ஈக்குவேஷன் மட்டும் ஷார்ட் ரிவிஷனாக பார்த்தோம். நம்ம ஒரு முறை பூரியன் சர்மாவும் லைட்லரும் ஆர் பிஎல் சோனி இந்த அவைலபிள் புக் ஒரு முறை நம்ம படிச்சுட்டு ஹேண்ட் ரிட்டன் நோட்ஸ் எடுத்துகிட்டு சிறப்பாக இருக்கும் நம்புகிறோம். இந்த வீடியோ தங்களுக்கு பயனுள்ளதாக இருக்கும் நம்புகிறோம். நம்ம சேனலை சப்ஸ்கிரைப் பண்ணலைன்னா சப்ஸ்கிரைப் பண்ணிவிடுவோம். ஃப்ரெண்ட்ஸுக்கு ஷேர் செய்யவும். நன்றி, வணக்கம்.